So we're Anemo Robotics, and we provide innovations for assessing marine biodiversity.
Yeah, so this is us. We are two of the co-founders in a group of 5 co-founders in total of Anemo Robotics. My name is Simon, and I have a background in technology entrepreneurship here from DTU, and then previously have an education in data science. So I've dabbled in kind of both computer vision and some business intelligence stuff, and this is also what I do at Anemo.
Yeah, and my name is Maria. I also am a recent graduate of industrial engineering and management. My background is in mechanical engineering, but then I decided to switch it up a bit and do more soft skills, I guess. And then, yeah, I joined Anemo as a co-founder, and in Anemo I'm doing more of the finance and business stuff. So yeah, as you know, we're in the middle of a biodiversity crisis. Almost 70% of wildlife population has shrunk in the last 50 years, and it's especially bad in marine environments. However, companies are determined to fix that with their biodiversity net positive initiatives. And as we can see, it's not only companies, but also the government. They have set aside €500 million to support nature restoration at sea. However, there's still one problem that persists, and that is that we cannot save what we cannot see. At the moment, this is how it's done today. You can see like an army of marine biologists going at sea. They collect data in a very dangerous way, like divers, and they also produce like very lengthy reports that don't tell people, companies, or anyone in general so much about how the biodiversity is performing. And then, of course, there's a lot of issue in the background. You can see like hundreds of hours of data, and that requires almost 5 times the amount of hours to process. And yeah, this is where we come in. We provide autonomous, continuous monitoring that's only non-invasive to the nature, but also saves a lot of time. And then we mitigate sparse and high-risk operations that are also very expensive. And we do that with our solution that is a camera that goes underwater for more than a month. And we also provide day and night monitoring at the 40 meters operation depth. And we do that, we take the data and then we process it with our AI platform. That's significant in time saving and also gives us a biodiversity score. And that provides a great value for our customers. We save them money and time, and we also give them a biodiversity score, and we help them achieve their sustainability goals.
Yes, so we've been at it for a little over a year now, and so far we've had various pilot projects to validate and test our technology. So we've been in the UK, we've had a few tests in Denmark. We've also been in Spain together with DTU, and then we have kind of a larger project coming up in Hundested Harbor in Denmark in like over the summer, which we're very excited about. And I want to get into some of the more technical stuff on how we apply AI to our solution, and I'll take the data and findings we got for from the Spain trip and kind of use that as a baseline for this presentation. So just in summary, what we're actually trying to do, we provide cameras for acquiring tons of raw data, and we then use computer vision to detect and count fish species of this data. And then finally, this is being fed into more of a business insights and analytics tool, where we can say something about whether or not abundance of a species increased and the overall health of an ecosystem. And of course, I could talk a lot about the two to the far right and left, but I'll talk mostly about some of our approaches to computer vision in this talk. So the technical challenges, these are obviously some of the issues we have to overcome, but also what makes this whole project kind of interesting to work with. When we're in Vigo, this is kind of snippets of some of the data that we acquired. And as you can see, it's quite varied. So to the far left, this is like the ideal setting with nice clear waters, nice lighting, not too much noise in the image. We also experience issues with like environments where we start getting a lot of plantation growth that can potentially confuse models. And then finally, of course, visibility is also not always ideal for this kind of stuff. And yeah, to put it into perspective, like this is all from a couple of 100 meters apart from each other, this footage, and it's within the same week it's captured. So environments can change quite rapidly. So that's the first challenge we kind of have to overcome with our solution. The second challenge is that, well, if to the untrained eye, if you look at these 5 fish, you might think that they look an awfully lot similar. But in reality, these are far from the same species, so our model should ideally be able to extract these very high-level features that each of these species has and classify based on this. So of course, this demands some pretty qualitative data to feed our model to actually learn these features. Yeah, but luckily though, it's not always the case that species are like similarly looking. So clearly we can see that these 2 fish are not the same, right? Except they are actually the same, and that again poses another challenge that we have to have data on different species throughout their life cycle to be actually able to distinguish between them. Yes, yeah, that's probably a good idea. Yeah, and finally, we have an issue related to the data acquisition and like data annotation. So obviously, we need someone very trained, like a domain expert, a marine scientist, or a biologist to actually be able to label this data. And it's not something that's in a high abundance publicly. So we have to make an effort to actually make sure that we are having like trained professionals to actually label our data to train a good model. And of course, this brings us to another issue, which is the fact that we have a lot of data, but it's hard to maybe target the data that's actually useful for our model to train on. And so this is kind of moving into the solutions to some of the issues that I've presented. And one of the approaches we have is using active learning. So we've looked into how we can set up a framework that takes a whole lot of raw data input and then have a framework for gradually adding more data to our models and continuously validating whether or not our model improves in performance. And we're doing this through uncertainty sampling, which is using something called entropy to find the frames in our footage that a model is the most uncertain about. And then this is usually a good idea to label this exact data and feed that into a model to quickly obtain sort of a more robust prediction, at least. The second approach we also have is we're looking into this hierarchical classification. So for a lot of the tasks that we face, it might not always be necessary to have like the most granular level of prediction, so on a species level. So as we know, fish follow sort of a taxonomy, and we've set up models so that we are able to, well, at first identify is this a fish or not in the image, and then gradually move through like the taxonomy, say can we reasonably likely say which species or which family a fish is, move down to something called genus, which is between family and species, and then ideally we are able to know which species it is. We also, so this is moving kind of away from some of the computer vision stuff, but we also, of course, incorporating some sort of geospatial data into our approach. So we are not, it wouldn't be ideal to train a model that can classify every fish in the world, because we'll usually just have one project in a specific location. So you can use open source data to make like a more narrowed list of what you're actually looking for when we apply cameras. Yeah, and so going back to some of the computer vision techniques we have, as some of you probably know, we're utilizing probably the most popular framework out there called You Only Look Once, or YOLO, which is a like a frame by frame. Oh, okay. There's supposed to be a video here, but maybe that got lost in the file sharing. I don't know. is there a way we can pull this up, or is it? Okay, yeah, it's a YouTube thing, but okay, that's a little bit of a bummer because this is basically highlighting how we take the input data and are able to draw boundary boxes around the fish and classify videos. So yeah, and again, okay. So again, YOLO frame by frame level classification. This is sort of a very standard way of dealing with this sort of data. We are also looking into using sort of more of a motion tracking approach. So what you can do is to actually detect movement in footage, and you can do that using, so we use optical flow and something called Gaussian mixture models to draw boundary boxes around fish. And then based on this can be fed into input in just a more of a normal convolutional neural network that's able to classify the movement as being a fish, a species, or just like the environment, basically. So that's kind of our approach. I'm hoping maybe I can share the videos later because it highlights a little better what it actually looks like in practice. Yeah. And so with this technology, it's been, quite a ride for us to start this whole project. As I said, only a little more than a year ago, we started out, with this thing, and we had our first prototype like in March 2023, and from there we've been a part of competitions, went on all these trips to test out our solution, and it's overall just been a super exciting journey for us to be a part of this. We managed to just get in contact with so many partners able to help us out, like with different knowledge sharing and also some soft funding, which is super awesome. It's enabled us to do a lot of stuff. Skylab, of course, also helped us get in contact with these people, so thank you. And the next big milestone for us will be the project that we have in July this summer in Hundested, which is a joint thing between us and DTU and other startups where we will deploy some artificial reefs and monitor those. So just, of course, we couldn't achieve this without a very, very good team, and these are the people who are involved currently. And I just want to shamelessly here at the end kind of promote that we're always looking for people to get involved with our startup. Specifically, like we can use a lot of different backgrounds, but I thought maybe in this setting I want to highlight that computer vision people are very much needed in our company, and we would love to get in contact with some of you guys if you think this is interesting. Write me or Maria or find us on LinkedIn. And I think with that, it's maybe we can take some questions. But thank you for listening in.
Yeah, I'm happy to come with the mic. So because we're live streaming, I'll bring the mic to whoever might have a question. Got one already?
First of all, thank you so much for such a presentation, and wish you the best in your endeavors. Two quick questions, technical. Why you choose 40 meters? The second one is, did you try any other technique of active learning other than entropy?
Right. Okay, so the first question, the 40-meter depth, right? It's more of like in practice, this is what our solution could work in an environment like this. In practice, the things we've been involved with never really requires anything lower than 8 meters. So if you were to monitor like an offshore wind farm, these are usually like in the near coast environment where you don't have to go that deep. So it's more of like to say we build something so robust that we could technically deal with 40 meters depth. But it's usually not the case that we'll go this deep. But it really depends on what project we're involved with, and you want to maybe monitor different layers of the water column basically to find different species. So
if you go deeper, what things would it change in the project?
right, we're mostly limited by the hardware then, so the casings that we're using wouldn't work, or it would probably leak. So that's the main thing. But of course, like AI-wise, we would have to see like what the data looks like. But it would probably look quite different from the Vigo data, at least. And then, sorry, your second question was entropy, right? Yeah, this is work in progress, I think. So we've been involved with a couple of projects where we tested out entropy as like an initial thing. There are different other sampling methods, and also sampling methods not necessarily related to uncertainty, but also just kind of, you can do some pretty advanced clustering, finding samples that look like the visual stuff look different, rather than basing it on the model certainty. So this is definitely an area where we could do more work, but yeah, entropy has proven to work like quite well for us, it seems. So yeah.
Yes.
Thanks for the presentation. I would like to know more about the performance evaluation, like how is the performance of such system, like in terms of accuracy and FS score, and plus the data sets, I guess it must be imbalanced, and how do you evaluate that?
Yeah, great question. So yeah, performance, it's of course dependent on a lot of things, and also, as you said, an imbalanced data set is obviously the main also issue that we're facing. So for the species that are like the most present in our training data set, we're achieving sort of so we're comparing it to a manual, like a scientist going through and labeling stuff manually, and we are achieving like a 80, at best 80%, but usually if the conditions aren't optimal, it's less than that. So we're not quite there where we want to be, but what I maybe also want to highlight is that we're usually involved in projects where we want to assess like how an abundance of a species has developed over time. So if we can just document that our model performs, consistently throughout time on newly acquired data, we can still say stuff about how the relative abundance of a species has changed, even if the performance is not quite where we want it to be. And then, how we combat the imbalanced data set. So there are some open sourced platforms where we can utilize data. So there's something, at least, I think it's a global thing, something called iNaturalist.com, where, just marine biodiversity hobbyists go in and maybe upload images that they've caught while diving or whatever, and then they'll upload that to this platform, and then scientists will help in identify and like classify what species is on footage. And so we've used that to basically grab data on the species that aren't really present in the, in our own data.
Who else
so that's
has
how
a
we are
question?
combating that.
Christian?
Thank you.
Thanks. Interesting. My question is on the model, or more specifically this combination of using YOLO, because I'm just using the standard YOLO package, and then how do you then combine this with this hierarchical classification?
Yeah.
Is it two different models that are combined, or?
So we have done some initial tests on, so we're using mostly YOLO, like the V8, one of the most recent ones. And the way we are incorporating the hierarchical, right now it's kind of a naive way of just having, a set of labels for like each step basically of the taxonomy. So you just predict on like a flat hierarchy basically, and then process that into saying how specific can we get in the taxonomy on our classifications. But there are like some YOLO models, like I think it's called 9000 or something, that utilizes these word hierarchies where you can manipulate these. So it actually has like a built-in feature where you can upload hierarchies of, let's say, the knowledge of a specific, like a tuna is a subcategory of a fish, for instance, and you can encode that into some of the YOLO models. But it's this is not something we've had that much success with, honestly. And then, sorry, did you have a question about the other model, the tracking thing? No.
No.
No. Okay, sorry. Okay, thank you.
So I'm curious, if you could give a piece of advice for the future entrepreneurs sitting in this room, what would that be?
I think like we've learned to maybe just, so it was a little nerve-wracking kind of reaching out to people in the industry at first, and like experts at DTU and whatnot. And I think an early finding was that people are actually very willing to help, and also to a degree where you would think they're spending a lot of hours helping you, but if they are like actually in on the idea and can kind of feel where you're trying to take this, I think we're surprised to find out how willing people are to engage with you if you just reach out.
Yeah, I think I agree with that statement. Like, use your network to the greatest extent that you can, and you never know what might come up, like potential funding applications or like even free advice. It's very helpful, especially if you're in the first stages of building your startup.
So don't reject yourself in advance on other people's behalf. Just let them be adults. They can say no if they don't want to.
Exactly.
Cool. Yeah. Let's see. Do we have more questions? Yeah.
Yeah, I have one more. It seems like you are only using 3 or 4 band images. Are you considering adding some active sensors?
Yes, but again, this has been like the primary focus. We're thinking of adding a few different things. So something that would be ideal for classifying, like if we have a big school of fish, like multiple fish in one place, we would ideally have like a depth kind of mapping of this. So either kind of a dual camera setup is kind of on the drawing board.
Yeah, and I would say there are also other emerging technologies in the field of marine biodiversity, for example, eDNA, which essentially takes a sample of the water and you can analyze that. And there are research suggesting that combining cameras and this eDNA gives you a better picture of what's there, because eDNA can give you the species, but you cannot get the count. So essentially combining the two is like probably the best way of getting like a very good picture of what's happening down there.
I think we have room for 1 or 2 more questions. Who should it be?
So could you comment on the uniqueness of the data that you have? Do you only use your own data? And also, it seemed like you remove a lot of the data that you actually record and only use some of it for training. Why do you not consider using all of it initially and then using the label part for supervised training?
Right. Yeah, so we are using some of our own data, but we also have an agreement with something called D2 Aqua. It's like the Institute for Aquatic Resources, and they had a lot of historical data that people already went through and analyzed by putting entries into an Excel spreadsheet. So we had a lot of a whole process of converting that into some actual annotations that's useful for computer vision models to train on. On the uniqueness, I'm not quite sure I've understood the way we've approached it. Is basically just that we have this big pool of raw data, and then we have an initial kind of just a simple model is the idea, at least just a binary thing that classifies whether or not some object in a frame is a fish or not. And then this is kind of what we're building upon. And that initial model is trained on a lot of stuff, also like some open source data sets. I don't know if that was answering it. Yeah.
Do we have a last question in the room? No, I think you answered them all. Thank you so much for enlightening us.
Thank you.